This video is on comparing dot plots. If we look up here at the shape, data can take three different shapes. These are dot plots. So if we look at this one and it just goes up and then down, that's symmetric. Looks like they're all over the place. This one's skewed right. That means you got most of your data to the left here. And this is skewed to the left when you got most of the data to the right. So they're opposites, so pay attention there. Excuse me. The variability or spread in the data points describes how far apart data is from one another. And this can also be represented by the range or interquartile range. You know, we've done that in a previous video. And the center, which is the median and the mean, both represent the center of the data. When the data is skewed, then the median is the best representation of the data. When the data is symmetric, the mean is the best representation of the data. All right, so we're going to look at these two dot plots, or we're going to plot these two here. All right, and we're having to do the median, and also we're going to put them in order, or we can put them in order. Let's do it out to the side here. This is room 434, and we have 3 4s, 4, 4, 4, 2 5s, 3 7s, and 2 8s. All right, so I'm going to plot that. I'm going to put dot plots here for this set of data here, and this is room 134. So I have 3 4s, 2 5s, 3 7s, and 2 8s. All right, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 3, 4, 5, 6, 7, 8, 9, 10. So I have them all. All right, and this is room 425. So I've got 2 4s. I got 1, 2, 3, 4 5s. 1, 2, 3, 4 5s. There's a 3 in the beginning. Missed that one. 3. And then 2 6s and a 7. So I've got a 3, got 2 4s, 4 5s, 2 6s, and a 7. So describe the shape of the two box plots above. Okay, this one is skewed. Which way is it skewed? Doesn't have a pattern. It's just really no pattern. It doesn't look like any one at the top. But we can look at room 425, and it's symmetric, right? So room 425 looks symmetric. If we look at this, what we can say about this one is it does have a higher number of minutes traveled to school. So room 434 has a higher number of minutes traveled to school. All right, if we look down here, what is the median of each data set? I wrote these out because I think it would just be easier for y'all to determine what the median number would be. So let's mark these out. Okay, we've got 7 plus 5, which is 12, and 12 divided by 2 is 6. So for room 434, it's 6 minutes. And if we do this one, 5 plus 5 is 10, and 10 divided by 2 is 5. So for room 425, it's 5 minutes. In question 4, how does the median number of minutes in room 434 compare to that of room 425? So room 434 is what? Is 1 minute longer? Let's look at the back here for this. Mark each of the following statements true or false based on the information. The distribution for room 434 is symmetric, while the distribution for room 425 is skewed left. So it's saying room 434 is symmetric. No, room 425 is. So that's false. The median number of minutes in 425 is greater than the median number of minutes in room 434. 425 is not greater, so that one is also false. Room 434 has a smaller range than room 425. So if we did the range here, the highest number is 8 minus 4, and that is 4. And then here it's 7 minus 3, and that's also 4. So one is not larger than the other or smaller. So that is also false. The distribution for room 425 is symmetrical, while the distribution for 434 has no pattern. Well, we know that's true. 45 is symmetric. So that one would be true. Okay. Set up a table to calculate the mean absolute deviation of each classroom. Once again, I want this on notebook paper, not this table. I want you to use the table that I give you. So we're going to do this here. So let's get the data for the first one. I may not have enough spaces. Okay, I'm going to put 2 in 1. So I've got 5, 7, 8, 8, 4, 4, 7, 5, 4, 7. All right, so there's the data for the first table. So we've got to calculate the mean. So let's add all these together. Got 5 plus 7 plus 8 plus 8 plus 4 plus 4 plus 7 plus 5 plus 4 plus 7. And that gives me 59. So I have 59, and I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide it by 10, and I get 5.9. So I'm going to put 5.9 here, all the way down this table. And you can make this table on your notebook paper. You don't have to have this copy that I have. All right, now we're going to do the subtraction. We got 5 minus 5.9. That is negative 0.9. 7 minus 5.9 is 1.1. 8 minus 5.9 is 2.1. We have that twice, so 2.1. 4 minus 5.9 is negative 1.9. That twice. 7 minus 5.9 is 1.1. We have 2 7s. And we have a 5 already, which is a negative 0.9, and a 4 is negative 1.9. So we have all of the values. Now we're just going to change them over to positive values. If they're already positive, there's nothing to change. And we're going to add those up. So we've got a 0.9 plus 1.1 plus 2.1 plus 2.1 plus 1.9 plus 1.9 plus 1.1 plus 0.9 plus 1.9 plus 1.1. And when I add that up, I get 15. And then 15 divided by 10, because that's how many numbers we have. And that gives me a mean absolute deviation of 1.5. So here's the table that goes with this set of data, and it gives you the mean absolute deviation of 1.5. Okay, this is room 434. All right, room 425. For this data, we've got 4, 5, 5, 6, 3, 6, 4, 7, 5, and 5. So I'll put that data there for this one. Move this out of the way. All right, so now I'm going to add them up and get the mean. 4 plus 5 plus 5 plus 6 plus 3 plus 6 plus 4 plus 7 plus 5 plus 5 equals 50. So right here I'm going to put 50, and it's 10 numbers. So that's going to give me the mean of 5. So I'm going to put 5 all the way down this table. And let's do the subtraction. 4 minus 5 is a negative 1. 5 minus 5 is 0. 5 minus 5 is 0. 6 minus 5 is 1. 3 minus 5 is a negative 2. 6 minus 5 is 1. 4 minus 5 is a negative 1. 7 minus 5 is 2. 5 minus 5 is 0. And 5 minus 5 is 0. So now we change all of these to positive. It's a positive one. Positive values. And then we add them up. So I've got 1 plus 1 plus 2 plus 1 plus 1 plus 2. And that gives me 8. And 8 divided by 10 gives me a mean absolute deviation of 0.8. So this is 0.8 mean absolute deviation for both of those. All right. So what observation can you make about the mean absolute deviation for each classroom? The mean absolute deviation for 434, I'm going to abbreviate it. .434 is equal to 1.5. The mean absolute deviation for room 425 is equal to 0.8. Room 425 has data closer to the mean. There's a little bit more with that 1.5. There's a little bit more variability for room 434. Room 434 has a mean absolute deviation that's almost twice that of room 425, because 0.8 times 2 is 1.6. So that's awful close. I really like doing mean absolute deviation, and I hope you do too.